Standing wave occurs when there is impedance mismatch between the transmission line and the load, which is the antenna. When there is an impedance mismatch, part of the signal is reflected back to the transmitter. This reduces the effective power transmitted and thereby the efficiency. Standing wave can be considered as a resultant of forward and reflected waves together. Standing wave ratio, or SWR, is the ratio between the maximum and minimum amplitudes of the standing wave. Highest level of SWR occurs when the antenna is not connected, open circuit, or when there is short circuit in the transmission line. SWR can be in terms of voltage, known as voltage SWR, and current, known as current SWR. Usually, it is the voltage SWR that is measured using an SWR meter. Ideal SWR is 1 and high SWR above 2 can cause heating of the transmission line and final power amplifier of the transmitter circuit and likely to cause severe damage. Now I am going to demonstrate how to connect the patch cable between the radio and the SWR meter and connect to antenna to measure the SWR. I am demonstrating measurement on VHF as my CP22E antenna is for VHF. Earlier I had checked the same antenna for UHF also and found that the SWR is 2.25:1. Now I am only demonstrating testing on VHF. This is the HLF 200 patch cable. HLF 200 is equivalent to LM 200. You can see that there is one PL 259 connection at one end. This is another PL 259 plug at the other end. So this is a short cable. Total length is very short. You can see that it is a short cable. This is a patch cable which we need to connect between our radio, which has an SO239 connector, and the SWR meter. This is the SWR meter I am going to use. Now this is the antenna cable which is coming from my CP22 antenna, which has been mounted outside. It also has a PL259 connector. So you need a patch cable to connect the SWR meter in between the antenna cable and the radio. As you can see, the SWR meter has connectors for antenna as well as the radio. I am connecting the antenna socket. The antenna socket has been connected. Next is to connect the patch cable. This is the patch cable which has been connected. The other end of the patch cable is connected to the radio. You have to make sure that there is no loose contact. You have to tighten the screw well so that there is no loose contact. Now the patch cable has been connected, antenna cable has been connected, and the radio is ready for testing SWR. The radio is switched on at low power because you have to test SWR always on low power before going for high power. This is a cross needle SWR meter. You can see one needle for the forward power and one needle for the reflected power. The markings in red will show you the SWR. So you need to have a low reflected power, and the power output should be shown in the forward power, and the SWR should also be low. I am going to press the PTT. You can see that reflected power is only minimal and the SWR is only about 1:1.1. Sorry. You can see that the SWR is only 1.1:1. So this is a good matching between the antenna and the radio. I am using HLF 200 cable CP22E antenna at about 9 meters from the ground and a low power in the radio. I was under the impression that both the built-in SWR meter of the radio and the external SWR meter, which is connected in series with it, will show the same SWR. My VHF dual band radio did not have an internal SWR meter, so I was unable to check this out. When I started using FT710 with a built-in SWR meter and automatic antenna tuner, I noticed that the readings are not the same in both. This was especially so after tuning on a frequency which had higher SWR for the antenna. When you tune the higher SWR to a lower one using the built-in antenna tuner, the radio shows a very favorable low SWR during transmission after that. In this video clip, the cross needle external SWR meter is showing an SWR of around 2.25:1, while the internal SWR meter is showing an SWR of nearly 1:1. When the PTT is pressed, the needle in the internal SWR meter can be seen dipping down to almost 1. In receive mode, the meter functions as an S meter and shows high value due to the ambient noise on the band. This video clip illustrates the higher SWR in both internal and external meters prior to automatic antenna tuning using the built-in antenna tuner in the radio. The previous clip was recorded after tuning to demonstrate the disparity between the two readings. Initially, I was worried as I had kept the display meter on power mode in the radio and was not seeing the SWR in the radio. But the red light indicating high SWR was not lighting up in the radio. I was wondering about that for a few days before I realized that the external SWR meter will be showing the SWR in the coaxial cable, while a lower SWR is presented to the radio by the built-in tuner. Further clarification of this fact was obtained by changing the display mode of the meter in FT710 to SWR instead of power. It consistently showed low SWR near 1:1 after tuning. This disparity will not occur if you use a remote antenna tuner at the antenna feed point. Though that is an ideal option, it will bring in more expense and complexities to the system. Remote antenna tuners are more expensive as they have to be weatherproof. Mounting them at the center of the half-wave dipole antenna requires additional supports to prevent sagging of the antenna. Power supply to the remote antenna tuner has to be with either a T-bias or an additional power line along with the coaxial cable is needed. If all these can be provided, a remote antenna tuner will give better performance in terms of radiated signal. I was never worried about SWR or standing wave ratio during my first stint in amateur radio in late 1980s. That was due to three reasons. 1. I did not know much about SWR. 2. I did not have an SWR meter, though I did homebrew an SWR bridge later on and tested SWR using an analog multimeter. 3. Most of my ham radio operations were with a homebrew vacuum tube radio, and vacuum tube radios are known to tolerate higher SWR than solid state radios. As a disclaimer, I did lose quite a few BD139 final transistors of my VU to VW and QRP radio, which was my first ever ham radio. Retrospectively, it could have been due to elevated SWR. Moreover, I was using 75 ohms television cable as feeder, as that was the only one available locally, and I did not even know that there is 50 ohms cable for ham radio. I had never tuned my inverted V dipole antenna or horizontal dipole, most often in V configuration due to the weight of the unsupported feed line. Still, I had reasonable success with local contacts on QRP on CWAM, while some of my friends could work plenty of DX with it. I could work a lot of DX, including the most difficult WLAN in those days on CW with my 3x807 vacuum tube QRO running about 120 watts and dipole antenna. In late 1990s, when I purchased a commercial TM261 VHF base station and a handy, I became more concerned about feed line, though still lacking an SWR meter for VHF. I moved on to RG213 cable and ground plane antenna tuned and given by my local ham friend. Still later, I had used 7-element Yagi with gamma match, again tuned and provided by another local ham friend. Then came a period of inactivity to return back to ham radio in March 2023 with a renewed license and a lot of interest and some more free time. Moreover, I had become familiar with how to get information from Google, Twitter and WhatsApp with plenty of inputs from the ham radio fraternity worldwide. Though the old TM261 is still working on low power, I have acquired a new IC2730 dual band radio. Now I have become really concerned about SWR, as I do not want my new radio to pack off due to high SWR. I had also purchased an SWR meter which could measure SWR from HF right up to 525 MHz. So I started measuring SWR for each and every configuration. My CP22E commercial VHF antenna had a low SWR of about 1.1:1 on VHF. Then some of my friends told me that it will also work on UHF as third harmonic, just as the 7 MHz dipole also works on 21 MHz. My CP22E has an SWR of nearly 1.8:1 on UHF on sunny days. SWR on both VHF and UHF rises when it is raining heavily, making me more concerned. Still, I do use it mostly for VHF transmission and UHF reception for VU FM satellite operations with fair results. UHF transmission for UV satellites has been successful only on very few occasions as expected. Though the old TM261 is still working on low power, I have acquired a new IC2730 dual band radio. Now I have become really concerned about SWR, as I do not want my new radio to pack off due to high SWR. I had also purchased an SWR meter which could measure SWR from HF right up to 525 MHz. So I started measuring SWR for each and every configuration. My CP22E commercial VHF antenna had a low SWR of about 1.1:1 on VHF. Then some of my friends told me that it will also work on UHF as third harmonic, just as the 7 MHz dipole also works on 21 MHz. My CP22E has an SWR of nearly 1.8:1 on UHF on sunny days. SWR on both VHF and UHF rises when it is raining heavily, making me more concerned. Still, I do use it mostly for VHF transmission and UHF reception for VU FM satellite operations with fair results. UHF transmission for UV satellites has been successful only on very few occasions as expected. It was with this background information that I read with great interest an article by KN0JI titled "An Excessively Low SWR Can Kill You." He has mentioned that our undue concern for SWR could lead us to repeated climbing on rooftops, which could be really dangerous, especially in adverse weather conditions. In fact, my second stint, he goes on to mention our two important concerns in case of SWR. One, we do not want to burn out the final power transistor of our radio because of high SWR. In fact, I have lost quite a few of them for my old homebrew QRP. 2. We want all the power from our radio to go out of the antenna and not get reflected back due to high SWR. He mentions that the first point is not much valid for a 21st century commercial radio which has a feedback mechanism to reduce power output or shut off the radio in case of high SWR. I think I have experienced this a few times in my IC 2730. Sometimes unlock appears on the screen and there is no power output when SWR is elevated. This does not appear when I try again on low power with the same antenna. Many modern HF radios have internal automatic antenna tuners which can take care of SWR up to 3:1. Regarding the second point of the power reflected back the antenna because of mismatched impedance, KN0JY informs us that this power is not really lost. It will get re-reflected back to the antenna when it reaches the radio. The process is repeated until the power is either transmitted or consumed by the coax. He mentions that, but I am not sure whether multiple reflections across the coax will impair the quality of the signal, as I would expect mixing up of reflected signal and the new signal coming from the radio, just as if you are listening to music in a room with too much of echo. Anyway, it is comforting to note that protective mechanisms built into modern radios would prevent damage at SWR up to 2:1 without any significant cut down of power. Even higher SWR may be tolerated in HF radios with an internal antenna tuner. I have seen a video online in which it was shown that the initial higher SWR drops quickly when the internal antenna tuner functions in commercial radio with automatic antenna tuner. So maybe we can save ourselves from multiple climbs to the rooftop. After all, you are more important than the radio.